to be doing observing at all. Of course, the moon will be quite late. I think around 2 or 3 in the morning. But if you are up real late or get up real early, the moon is very nice out there with, of course, Mars, Jupiter, Saturn, and Uranus with binoculars. Now, the moon is actually how I'm going to get us to your first item, actually. So let's do a little bit of this week in space and astronomy and history. It's just the two of us, so we'll do a few items. And Sana, I believe you have a moon-related one.
Yes. So this was the launch anniversary of the Chandrayaan-1 spacecraft. Chandrayaan-1 is a lunar orbiter and impactor pair that was launched and operated by the Indian Space Research Organization, the ISRO. Chandrayaan-1 was a really great mission. It was pretty significant, not only because of its scientific discoveries, which it made quite a few amazing ones, but also because it marked a couple firsts for the ISRO. This was their first deep space mission, so their first mission to the moon. And the use of the moon impact probe, which impacted the south pole of the moon, made India only the 4th country to ever reach the lunar surface, either through an impact or through soft landing. So they were only one of 4 for quite some time after the Soviet Union, the United States, and Japan. So Chandrayaan-1 launched on October 21st from India's spaceport. The spacecraft carried 11 instruments. 5 of them were created by the ISRO, and then another 6 of them came from other space agencies, so NASA and ESA, as well as some other organizations that were affiliated with them. And like I said before, Chandrayaan-1 made a lot of really great discoveries. It created a lot of data that's still being used and analyzed today. But I want to talk about probably the most significant thing that Chandrayaan-1 discovered, which was that it found evidence of water ice on the surface of the moon. This is something that had been predicted by scientists for quite some time. It's kind of hard to find, though, because a lot of craters on the moon, a lot of the surface is fully illuminated by the sun at some point or another, and that'll heat up the water, causing it to evaporate, so we won't be able to find it, even if it was there in the past. But the idea behind this water ice existing on the moon was just that there are some craters, mainly around the poles, which are pretty shielded from sunlight. So if water ice does exist in those craters at some point, there's nothing that's going to evaporate it. And it'll stick around there for a very long period of time, making it possible for somebody to go along and find it. So it was the presence of water ice on the moon was something that had been suspected for a long time. But Chandrayaan-1 was the first spacecraft to actually go and confirm that water ice does exist on the moon. They used 2 instruments to do this. The first instrument was the moon impact probe, so the lunar impactor. It had been released from the spacecraft on November 14th, which was only a couple of days after Chandrayaan-1 had been placed in its intended lunar orbit. It traveled for about 25 minutes, during which time it turned on a bunch of instruments, started taking data during its travel to the surface of the moon, and then it impacted the south pole of the moon and the Shackleton crater. This got some preliminary data that did suggest that there could be water ice on the surface of the moon. It wasn't enough to fully determine that there was water ice on the moon. And that evidence was provided by the Moon Mineralogy Mapper, the M3 or the M-cubed experiment, which was a NASA experiment. With the addition of data from the M-cubed experiment, which just kind of looked at the way that the surface reflects infrared light, Chandrayaan-1 was able to find definitive evidence that there was water ice that exists on the moon. So a lot of this water ice was found in the South Pole, where the moon impact probe impacted the moon, but they also looked in other places in the moon for evidence of any water ice, and they did find more in the lunar North Pole. So that's where most of the water ice is on the moon, which is in the lunar north and south poles, which kind of makes sense because those are the areas of the moon that don't get hit with a lot of sunlight. There are some areas that are very well shielded, which is where this water ice exists. So, of course, the Chandrayaan-1 mission generated a lot of other data that's been very useful. It's created these really great 3D maps of the surface of the moon, also these maps of the chemical composition of the surface, just did a lot of things that would help study the history of the moon, so its formation and its evolution. But I think that this discovery of water ice was probably one of the really great discoveries that came out of this telescope, or not this telescope, but the spacecraft.
Absolutely. What a wonderful mission all in. And definitely a great time, and, I say very historical. So recent history, 2008, but very, very historical. And this is something that's going to continue to be important for so long. And the Chandrayaan-1, they didn't just do all of this. They had, amazing discoveries. They had a hugely successful mission, but they also had a huge amount of innovation in terms of the whole project for Chandrayaan-1, in that they were able to keep it down to $48 million for the whole entire project, I believe, was the full cost, which sounds like a lot to an individual, but for this kind of mission, that's a really good deal. And what they've managed to achieve here and what they've built with it is going to be so important for our, the whole Artemis 1 project, and this idea of even building, settlements on the moon. And not just that, but of course, the obvious question of, well, where did the water come from? Was it really comets? Or how are we going to get there? Who's going to test it? So it generated a lot of extra interest in the moon and what we can do there. And the technique they used for the water detection, that looking for hydrogen, is something that's also been used on other planets in our solar system, and might even be something that we can use in exoplanets someday. So just amazing mission all around.
Yeah. It's something that that's the great thing about a lot of these, is you get a lot of great science out of them, but you also just learn a lot, like technology-wise, like this, like the stuff that they learned even just launching this mission independent of the science is something that could be used for future missions as well. So you always get a lot of great things out of these missions.
Yeah, and huge congratulations to the ISRO. I can't wait to see what they do next. Maybe exploring other stars, which is how I'll get to my news item. Speaking of other stars, the moon, as we all know, is very, very far from Earth, but it's extremely close in terms of literally anything else in space, because all of our planets and our whole solar system, it just takes so much time for anything to get anywhere. 8 minutes for light to get to the sun. And if we want to go to another star, it's light years. So the very, very closest star to us, Proxima Centauri, is part of this Alpha Centauri system. And this is a really, really interesting system. It's one of my favorite systems. It is the closest to Earth. And on the 17th to 18th of October in 2012, they thought they had found an exoplanet on Alpha Centauri B, which they called Alpha Centauri B, just to be extra confusing. This discovery was announced in 2012, and it took 3 years before they were actually able to prove it was in fact a false finding. And this is, I think, a great moment in history, because it's a really interesting way of being wrong. When detecting extrasolar planets, very, very often we have to use indirect sorts of mission. Sorry, I swallowed a piece of dust there. Indirect methods. But when we're looking at things like the moon, we can use satellites to crash into them. We can send missions fairly easily, and using that hydrogen as an indirect proxy for water, as they were with the ISRO mission, the Alpha Centauri system is so much farther away. We can't send even a small spacecraft, and there are possible missions that haven't been launched yet that say, okay, well, maybe if we made the spacecrafts really, really, really small, we might be able to put solar sails on them and accelerate them with lasers and eventually get to Alpha Centauri. But it would still take decades at least. But how are we going to find them if we can't go there? If we can't really see them, we look for the effect of the planets on the stars, either through their spectra or through their motions. And there's a great quote. So the Alpha Centauri system, for those of you who don't know, it's got two stars which are very much like our sun, Alpha Centauri A and Alpha Centauri B. They're almost identical to our own sun, which makes them really interesting in and of themselves. But they're in a binary, and how stable planet formation is in a binary star system is somewhat unknown. We don't have a lot of binary systems really, really well mapped, and especially we don't have their planets very well mapped. So finding planets around a binary, especially the closest binary to us, would be really, really interesting. The primary and companion are A and B. So those two stars are the two sun-like stars. They've got a period of about 79, 80 years or so, and they're reasonably far away from each other. There are some stable orbits that you could put an Earth-like planet, and actually it has been mathematically modeled, and this is a popular project to give your beginning physics students, by the way, make a gravitational model just using the gravitational force of those two planets, and you'll see that you can put an Earth-like mass at 1 AU or 1.1 AU away from either of these stars and have it be completely stable gravitationally. But no planets were found. There are some planet candidates, and this is the interesting part. There are planet candidates, but there's no confirmation. We're not sure. So where are the planets in this system? Well, as of 2022, all the planets we know of are around Proxima. So Proxima Centauri is very, very different. There's some argument to be made that it might not be fully associated with the other two stars. It's got a wide orbit outside of Alpha Centauri A and B, and it's what's called a flare star. It's a low mass star, small main sequence red dwarf. It's much, much fainter than the sun, so 20,000 times fainter, and its mass is just a small fraction of the mass of the sun, so about 0.12 our sun's mass. It's a dim, small, fainter star that's quite a bit big distance from the Alpha Centauri AB system, and it is the closest to Earth. So that's the one that's just a bit farther away, but on the I suppose sun side. So it's got its that's where we say it's 4 light years to the nearest star. Well, it's actually more like 4.246 to Proxima and 4.344 to the AB system of Alpha Centauri. So they're not particularly close by each other, and there's a lot of mystery around this system, and it's been one of the ongoing, I suppose, thorns in the all planet fan sides that it's so difficult to get and see and discover planets around this closest system to our sun. So they were very excited back in 2012. This Alpha Centauri BB discovery. It was found to be a false finding, and it was thought to be around the B companion, which would be a stable place for it to live. If it was close enough to just that one sun-like star, it could have basically the effect from that one star's gravity. It's kind kind of like how, if we put a satellite in orbit around the Earth, we don't have to worry about the sun stealing it. It's much, much closer to the Earth. So the closeness wins, basically. That's a very short summary of the laws of gravity. But this particular question, dust in the air tonight, this particular detection had quite a lot of observations, and they were observing from February 2008. They had 459 observations of the spectra of Alpha Centauri B over a 4-year period. They used statistical filters to remove sources of variance, and this is where you get into trouble, because when you're introducing statistical equations into a natural signal, things can happen. And they did use Doppler spectroscopy to search for a planet, but only after cleaning. And so they basically had a weak detection, but it was seemed like a very promising one. And the announcement was an Earth-mass planet in orbit around Alpha Centauri B. This did get a Nature publication, which is on the grand list of Nature publications that probably shouldn't be. But it's was finally fully disproved in 2015. So 3 years after the initial finding, a lot of people started checking up on this interesting data, and using the same data, a different team found the signal was actually not caused by a planet, but it was a mathematical artifact of the window function used to create the time series for the actual observations. So if anyone's thinking about making eclipse observations or exoplanet observations, your resolution in time space matters so much, and how you set it up is vitally important. So by having mathematical artifacts in their data, they actually introduced a signal, and it wasn't really there. So the team who disproved the result, in October, actually 3 years later, they actually replaced the astronomical data with random noise, which you can generate various different ways. And if you can find a signal in random noise, then you have definitely done something wrong to your data. So it's a great discovery, disproval, I suppose I should say. And the final conclusion was that both groups agreed there was that it was a mistake in the analysis, and the planet probably did not exist. So there are other signals around Alpha Centauri A and B that could be promising, but they're not statistically significant, and the bar is very, very high, especially now that there has been shall I say, an incorrect prediction. So when we say that they have 3 planets around Proxima Centauri, you can be sure that those have been very, very verified. And I believe there actually is a possible 4th planet for Proxima Centauri as well. So it's very, very interesting system. If all the planets really are around Proxima Centauri, it's a bit too bad because it is a flare star. So that would make life as we know it very hard to manage. So this week in history in 2012, October 17th and 18th, scientists came together to help other scientists, and we eventually found that there weren't any planets that we could confidently say were around Alpha Centauri B. But we have since found other planets around Proxima, and it doesn't mean they're not there. It just means we don't have the techniques and the data to discover them yet. So we'll have to keep working on those spaceships, I suppose.
Yeah, that is so frustrating that it was a processing technique error.
You need a big megawatt transmitter.
Yes, as you read it, you are actually reading the nightmares of every astronomer who's ever produced data, because that's always the fear, that you're going to introduce some error or you're going to make some mistake that compromises the data, because what you don't want to do is introduce any signals that aren't real, and you don't want to subtract any signals that are real. So you want to get rid of noise, but you have to be so careful, especially in these extremely delicate types of transit interactions. However, I will say that there is some hope as well coming on the JWST front. So Sana, I just had to loop you into that because we do have the JWST Go Cycle 1, I believe, has one of these as its target. So I forget exactly which one. I think it was the Alpha Centauri system, but I could be wrong. We can't talk about JWST too much on this show. I think it was Alpha Centauri A. So Go Cycle 1 observations for JWST would be specifically looking for planets around Alpha Centauri A. And there is a candidate Neptunian planet. Candidate 1, as it was called, was detected around Alpha Centauri A, thought to be in orbit at 1.1 AU. Not confirmed, but maybe with this JWST Go Cycle 1, they'll finally be able to get some convincing confirmation, and we'll be seeing planets, which would just be so cool.
Puffed up ideas of national destiny,
or even a domestic. I'm trying to just look up which observation that is, but I can't find the program.
The most I found about it was that it's planned Go Cycle 1 observation, and it is definitely Alpha Centauri A, because that is where they have candidate 1. That's the one where they have a possible sort of Neptune mass or so, question mark sized planet. And if it's in 1.1 AU, that would be so interesting, because that would be a Neptune type of planet, a Neptune mass planet, but not at the orbit of Neptune. Our Neptune is way out there in the icy outer solar system, completely frozen. This planet would be up inside of the ice line in the nice, warm, toasty, Earth sort of region. That would be just so interesting. And of course, JWST looking in those infrared wavelengths should be pretty well suited for this.
We also ask, why is the nation state the right collective?
I cannot find. I was wanting to look it up, because you can look up like the when they're observing it and everything, but I can't seem to find the program. I found stuff about it online. I just can't find anything on Space Telescope's website.
Well, we'll leave it as an exercise for the listener then.
Whoever wants to do the hundreds of Go programs for JWST.
Yeah, and as a reminder, although Alpha Centauri A and B are binary stars in a reasonably close orbit at 1 AU, this candidate 1, if it's confirmed, would actually be in a completely stable orbital spot. It wouldn't get any interference from the other star. So there are some very interesting transits. And who knows, maybe they'll find an Alpha Centauri BB after all. All right, so probably moving on from our slight aside here into exoplanets and adventure. Watch out with your data reductions, everyone. We'll go ahead and go to a little bit farther back for our next This Week in Space and Astronomy History. Speaking of interesting programs and interesting satellites, Sana, you've got a really good one here.
Yeah, so So this is October 18th, 1989, which was the launch of the Galileo probe. Galileo was a Jupiter orbiter that also had an impactor for Jupiter as well, which was launched and run by NASA. Galileo itself was deployed from the cargo bay of the Space Shuttle Atlantis on its launch. The Galileo was just like Chandrayaan-1, was a very significant mission. It had quite a few firsts for space exploration. One of which was it was the first probe to actually orbit Jupiter. Jupiter had been visited 4 times already by other probes, Voyagers 1 and 2, and I believe it was Pioneer 10 and 11. But these missions were just flybys. They did get a lot of great observations of Jupiter, but it's a flyby mission, and there's no comparison for sending something to a planet and staying in orbit around it for years collecting data. So that was one of the major firsts of the Galileo probe. On top of that, a lot of the firsts of the Galileo mission happened before it had even arrived at Jupiter. So the mission and the probe didn't have enough fuel. They didn't really have the capabilities to just launch it and go directly to Jupiter. So it ended up taking this 14-year trek through the solar system to actually get to Jupiter. It swung by Earth twice and Venus once to get gravity assist to fling it to the outer solar system. And while it was doing those gravity assists, the team turned on some of the instruments, tested them out, took data, which included studying Venus's atmosphere. So it was able to get some good observations of even just the inner planets, even though that wasn't the intended purpose of the mission.
It's just not
a little further out into its mission, once it exited the inner solar system, it performed the first ever flyby of an asteroid. It was the first spacecraft to ever fly by and study asteroids in the outer solar system. So it actually did flybys of 2 asteroids, Gaspra and Ida, and even found a small moon called Dactyl that was in orbit around the asteroid Ida. When it got even closer to Jupiter in 1994, only around a year before its orbital insertion into Jupiter, it was even able to observe the impact of comet Shoemaker-Levy 9 into the atmosphere of Jupiter. This comet had broken up and eventually just kind of crashed into the atmosphere of Jupiter, leaving some very noticeable patterns on its atmosphere, which Galileo was able to observe while it was on its way to Jupiter. So just kind of a good timing coincidence for that probe. So finally, fast forward to December of 1995, Galileo was inserted into orbit around Jupiter. And at around that same time, the impact probe actually impacted Jupiter's atmosphere. This marked yet another first for this mission because it was the first time that an impact probe had plunged into the atmosphere of a gas giant like Jupiter. It was able to reach a depth of around 200 kilometers into Jupiter's atmosphere. It collected and transmitted data for about an hour and just provided a lot of really great observations about the planet's atmosphere. So things like its chemical composition, its weather systems, clouds, its thunderstorms that are much more massive than the Earth. So it really did give a lot of great data about the atmosphere of the planet. Galileo did so as well. It really revolutionized the way that we see Jupiter, not just the planet itself. So not only observations of its atmosphere and its weather system, Galileo also took amazing observations of Jupiter's magnetic field and its rings. It discovered that the origin of the very thin, dark ring system that is around Jupiter actually comes from when meteoroids crash into the surfaces of the 4 Galilean moons. It ejects stuff into space, which ends up orbiting Jupiter in that ring. And on top of all of that, so the great observations of Jupiter, its magnetic field and its rings, probably some of the best observations it took has to do with Jupiter's moons. And I'm kind of biased in this respect because I think that the moons of Jupiter and Saturn as well are some of the most interesting objects that we have in the solar system. But because Galileo was in orbit around Jupiter, it could do flybys of these moons pretty regularly and really collected a lot of great observations that kind of showed us how dynamic and amazing these worlds are. So just a couple examples. It observed the moon. It did several flybys of the moon Io. Io had previously been observed during Voyager 1's flyby years earlier, which revealed Io to be volcanically active. But Galileo's observations really revealed it to be an incredibly active world with a ton of volcanoes. It might be the most volcanically active celestial body in our solar system, actually. It took a bunch of observations about, in part, the composition of the lava as part of these volcanoes, which is mainly silicates with a lot of magnesium in them. It also observed the moon Europa. Europa is pretty young. It has a pretty young surface, so it just took images of Europa that showed that the surface is relatively crater-free, which makes it a very young surface. And it also observed these massive cracks on the surface of Europa, that underneath which exists this huge subsurface ocean, which I think has more water in it than the Earth does, in this little moon around Jupiter. So it really revealed it to be a crazy dynamic world, Io and Europa as well. And on top of all of that, it found evidence of a magnetic field on the moon Ganymede, in addition to Jupiter's crazy magnetic field. Ganymede also has one, which is a very, very interesting discovery. So all in all, the mission lasted for about 8 years in orbit around Jupiter, on top of the 14 years that it took to get to Jupiter. It ended in September 2003. The mission, thankfully, was decommissioned. They didn't lose contact with the spacecraft or anything. It was a planned decommissioning where they crashed Galileo into Jupiter. And the reason they did this is simply because the spacecraft ran out of fuel, they had no way to control it, and they didn't want it crashing into any of the moons, particularly Europa, because they discovered this great subsurface ocean, and where there's water, there could be life. So they just wanted to make sure that they didn't unintentionally crash this probe into Europa and mess up any chances of life appearing on the planet, or not on the planet, on the moon. So they intentionally crashed Galileo into Jupiter to protect Europa. So it's quite an exciting end to a really amazing mission, which launched on October 18th, 1989.
Absolutely, and it was just so exciting, as you say. It is quite funny, though. This is we have developed a bit of a theme of, when it's crashed on purpose, we usually call it, deorbited or targeted. But not running into Europa also means that if we do ever find life on Europa, there's a good chance it didn't come from Earth, right? So that's one of the things we can rule out by eliminating the chance for contamination from an Earth craft. That said, I mean, the radiation belts around Jupiter are pretty heavy duty. Galileo did survive, but it might have provided a little bit of sterilization there. And the whole system is just so interesting. And with these massive planets, Jupiter and Saturn, they have these huge moon systems, and it's almost like they are miniature solar systems in and of themselves, especially Jupiter. It puts out its own heat. It provides tidal heating with the other moons of Jupiter to sort of, give that Europa a good squishing and get liquid water there. And so you have the same kind of thing as for the moons of Jupiter. Jupiter is the system. And there's just so much going on. You're absolutely right about Europa, by any estimates that make sense, does have more water than all of Earth. So if you were to ball up all the water in all the oceans on Earth and compare that to the water of Europa would have more. And it's a very, very, very watery world covered with a really interesting icy crust. And I know there's a lot of people who just can't wait to send submarines to swim around in the oceans and investigate and look for fish.
There might be something there.
Oh, there very well might. It's got water, it's got heat. And the question has been, what else do you need? On Earth, we think life developed somewhat naturally in those conditions. If there are lightning storms to inject energy around Jupiter's atmosphere, who's to say that there's not some sort of high energetic particles interacting under the oceans of Europa to create its first life? That would just be so neat, and we're just not going to know until somebody does get that space submarine working.
All this and more today on
I think there were plans I can never remember whether it's to go to a moon of Jupiter or Saturn, because both of them have such fantastic moons. But
yeah, there have been several submarine type of plans for Europa, but the technical difficulties are quite high. The robot submarine on Europa is kind of a top wish for lots of planetary scientists. I know it's been going around heavily since 2012. The Europa Clipper, I think, is the one that has the farthest development. And I think that one did contain some form of submersible. I know it has a spacecraft in orbit. And what was it? I think it was just flybys, though, the Europa Clipper. And we've gotten a lot of flybys. We've seen water plumes. We've seen water leaking up from the cracks in the ice surface of Europa. And so it's really just tantalizing us. But yeah, you would need some sort of submersible with a way to communicate to the outside world. How that would work through a thick ice crust, I just don't know, but I hope they get one.
Yeah, that would be very cool.
Europa, Ganymede, they all deserve to be explored more, as do the moons of Saturn, and not to miss out the moons of Neptune and Uranus as well.
If space agencies had unlimited budgets to do whatever they wanted.
Well, it has been mentioned as well. A lot of these missions are not as expensive with these smaller orbiters. Orbiters tend, and especially now that we have these shoebox satellites and small satellites that can be launched easily, with the DART mission that we might talk about later if we don't run enough time, they even launched a CubeSat to watch the impact as DART was going in. So with more CubeSats and more CubeSat launches, maybe we will start getting more close-ups. Submarines are going to take a lot more work, though. Anyways, very, very fun stuff. Love Galileo, and lots of really great thought projects we can do about the moons of Jupiter. Hopefully we get some more missions out into the outer solar system. I have one last item here, which I'll probably be a little bit quick about, just so we can get to some news items. But not to end anything too quickly. We're going to do our last This Week in History as a semi-recent event again. So going actually fairly recently, we've had a huge number of history-making space events in the last few years. You could say that it really kicked off in 2019. We had a lot more launches happening, of course, with SpaceX and NASA and Virgin Galactic and then Blue Origin, and all kinds of things happening, more people getting into space, more activity at the space station. And in 2019, we had the first ever all-woman spacewalk. And this was astronauts Christina Koch and Jessica Meyer on October 18th, 2019. Now, they're both back on Earth, but as mentioned before, this was, in fact, one giant leap for womankind, because it had never been done before. The astronaut corps was notoriously male-dominated, and so actually having a first ever spacewalk by an all-woman team was a nice point in history. This was these spacewalks are called extravehicular activities, where the vehicle is the space station, And this started nice and early, so I'm guessing they're on Eastern time, but it was 7:38 Eastern time, and it went a little bit ahead of schedule. So they basically had to go into battery power in their spacesuits, and they had capsule communicator Stephanie Wilson on the ground. They had fellow astronauts located on the ISS, and they were, as they say, the first all-woman spacewalk team. This was the fourth for Christina Koch, I think, or Koch, and Meyer's first spacewalk, and it was pretty interesting little moment of history. The astronauts were all having a lot of fun on this spacewalk. If you ever go and look it up, Christina Koch and Jessica Meyer, there's a lot of pictures of very, very big smiles from the International Space Station once their walk was completed. It has the honor of being the 221st spacewalk, and it was in support of the space station's sort of maintenance and assembly. So the very first woman to do a spacewalk in 1984 was cosmonaut Svetlana Savitskaya, and I'm sorry if I'm saying her name a bit wrong, but since 1984, all of the spacewalks that happened, there were only 15 women going into spacewalks at all. So this is quite a bunch of records, actually. And Koch, she had not just the fourth spacewalk, but also made history in December, as she set in December of 2019, I should say. She set a new record for the longest amount of time continuously spent in space by a U.S. woman. So this beat former NASA astronaut Peggy Whitson, who had 288 days. So the spacewalk was, pretty important. It received a call from the White House, and there was a lot of very, very happy astronauts coming back into the ISS and celebrating. And this is the 42nd time that women have participated in a spacewalk, but it was the first time that they actually had an all-female crew. Lots of great views coming in from the cameras around the space station, and it's a milestone from 2019. But the hope was, by I think most astronauts there, that this will now be considered normal, and not to overshadow all of the people who've been doing spacewalks for 35 years. It'd be nice if it was just a normal activity and not the first time ever. So the spacewalk itself was originally going to have the two astronauts swap out old nickel hydrogen batteries. Nickel hydrogen is not the newest technology, if you know anything about battery technology, and they would put in new improved lithium ion batteries. And battery technology and space technology have often gone hand in hand. The very first solar power and solar batteries came from space development, and this recent battery upgrade was the original plan, but once they were ready to go, they found there was an issue with one of the 24 battery charge discharge units. So they actually worked together to replace that BCDU, as they say, and that is a hardware connected to the space station's solar arrays. So solar power and battery power are hugely important for the International Space Station, and a lot of that development in solar power, I just have to say, I'll slightly spoil one of our news items. Battery technology has actually just made the news again recently for huge improvements in charging on electronic batteries. So it's been, very, very interesting first for human spaceflight, very exciting for, I think, everybody who saw it or heard about it. And, the idea that space is available to everyone is integral, I think, to this upcoming Artemis program, which we're all very excited for. Currently working to land the first woman on the moon in 2024. I think it's still. I keep being shocked that it's not been pushed forward, but it's all happening now. So it's part of a really exciting time in history, and this was a little callback to 2019. Huge congratulations to astronauts Christina Koch and Jessica Meyer on their first all-female walk outside the International Space Station, and of course the repairs that they did there. So I should probably actually just stop here to go ahead and remind everyone you are in fact listening to York Universe, broadcasting live from the Allan Carswell Observatory, located at York University in Toronto, Ontario, Canada. If you have any questions, you can swing by our website, observatory.info.yorku.ca, follow the links for OPV, and have a chat with our crew over on YouTube, who are currently showing pictures and giving live astronomy chit-chat. Tonight you're listening to Elena and Sana, and we're discussing all kinds of fun new stuff. So Sana, we did have a couple little reminders and news items. Do you want to quickly just make the Orionid reminder?
Yeah, so there is the peak of the Orionid meteor shower is happening on Friday, October 21st. The peak is actually at around 5 a.m., so very, very close to sunrise this time around. As the name suggests, the radiant point for this meteor shower is the constellation Orion, which will be rising in the south overnight on Friday, October 21st. So basically, if you want to observe this, just get as far away from light pollution as you possibly can, hopefully not somewhere around Toronto, because the light pollution around here is horrible. But hopefully about 15 to 18 meters per hour if you're in dark sky conditions, so it should be a nice little meteor shower to watch this week.
Absolutely, and as we mentioned before, if you are out looking uppity, you can also see Saturn, Jupiter, Mars. The Pleiades is out. You'll have a meteor shower. This just sounds like an amazing chance to pull out the lawn chairs and bring a blanket. If you've got binoculars, you'll see Uranus as well. Lovely, lovely stuff. And I will say that as far as reminders go, I do want to remind our listeners that the Allan Carswell Observatory will in fact be doing a Halloween telescope event on October 31st. The Eventbrite tickets for this event will be listed on the website, so don't miss out. Make sure to get your ticket if you think you would like to come and see a haunted telescope. And then I think we'll go ahead and try to get a little bit of news items. Sana, would you like to do the Arecibo one?
Sure. Yeah, so I will keep this fast because we're kind of running short on time. But before I get into the news update, just a little background on the Arecibo telescope. It was this massive 305 meter diameter single dish radio observatory in Arecibo, Puerto Rico. It was the largest single dish radio telescope for a very long time, since it was commissioned in 1963 up until about 2016. It was unfortunately decommissioned in 2020. They did have plans to decommission the telescope, but it just sort of took care of it itself before anybody had a chance to do any decommissioning. Basically, what happened with this telescope is that there was a massive 900-ton science platform that had been suspended above the 305-meter dish, which it had things like receivers and some instruments on it that the telescope needed to operate. There were some issues with the cables that held it up. One of the cables slipped out of its socket. Then in October 2020, one of the main cables broke. The National Science Foundation that funded Arecibo, after that cable snapped in October 2020, they decided this is too risky to fix. We're just going to decommission the observatory and then figure out where to go from there. But before they had a chance to safely lower the science platform, another cable snapped in December 2020. The thing just came crashing down, destroyed the disk, and that was it for the Arecibo Observatory. A lot of astronomers had been hoping that the NSF would decide to rebuild Arecibo. It was such a great research facility. It had its fingers in so many different projects. It had involvement in radio astronomy with study the Earth's atmosphere. It was even working as a radar observatory, so doing radar observations of planets and asteroids in our solar system. It was also just a great thing to have in that area because it did a lot of work in science outreach and education. But unfortunately, last week on, I think it was the 13th or 14th, the NSF announced that it would not be rebuilding the Arecibo Observatory. It's just they're gonna shut down the observatory. The research capabilities or the research area of Arecibo is not going to be receiving any more funding, unfortunately. That said, they are not shutting it down completely and are instead replacing it with an education and research center. So they're basically just wanting to build off of Arecibo's past work in education and outreach and make it, just turn it fully into an STEM education center. So if all goes according to plan, it'll be opening in 2023 under the new name, Arecibo Center for STEM Education and Research. So this is definitely sad news that they're not going to be rebuilding it. Arecibo was losing it was such a huge loss to astronomers because it did so many great things, and it was also just a really great telescope. So definitely very sad that they're not going to be rebuilding it. I know a lot of astronomers, from what I've read, are not very happy about this, but at least the place isn't being shut down completely, and it'll still, continue to do something for the community and science education research.
One was that there was this kind of global consensus.
No, that it is very, very sad, and I think all of us who watched the collapse videos, it's always really sad to lose one of these amazing facilities, and especially with the cable breaks being, as they say, somewhat due to lack of maintenance because of lack of funding. It was preventable, or at least it seemed very preventable, and it's it is really sad to lose this kind of not just valuable astronomical facility, but hugely historical. I mean, it wasn't just it wasn't just used for discovery. It's literally one of the pictures on the Voyager Golden Record. It's like, wait, but we saw this record out. If aliens do find it, they won't even be able to know it's us because we don't have the observatory anymore. But yeah, it's a great disappointment, especially because it's it was doing so much with so little, and it struggled along just on shoestrings for years and years until it finally collapsed, and then they said, oh well, we're not going to support it. It's kind of like, it is, as you say, very, very sad for a lot of people, and I think not just astronomers. It does at least have somewhat of a replacement with the FAST telescope, as you say, the 500-meter aperture spherical telescope in China. But it's kind of, it is also very historic. And I mean, this was the telescope that was in, the James Bond GoldenEye film.
So you're saying
was it even a movie star?
It's even been a movie star, and it kind of was one of those things that people had really started to rely on. It was upgraded quite a few times, but it did have its funding sort of cut, and then it was no more. But yeah, it was especially, I think, the part that gets me is the possible preventable part. But as you say, at least there is an educational center coming, and we'll always have our fond memories and our data.
Skin color, and yet we think of India as a kind of brown country, or the people,
especially the data, I suppose, with the archive technology now.
Very, very black. just because we have these
people
social
can
categories
still
and we have
will still publish papers with Arecibo archival data.
Social categories look like.
Absolutely, and if you are interested in Arecibo archival data, I actually would encourage everybody to go and have a look and see if there might be some that you want to reduce and investigate. That's it's a wonderful legacy to leave behind. Is their amazing data collection and observations.
Every day.
All right, so I think that's basically all we have time for. I did mention a little bit about battery technology, but we'll leave it for next time. We've been having a wonderful time this evening, despite there being a little bit of sad news. But everyone, you have been listening to York Universe, the astronomy and astrophysics program written and presented by the students, faculty, alumni, and friends of York University. The hosts this evening have been Sana and Elena. Stay tuned because it's Astronomy Night in Canada. Coming up next is Quirks and Quarks, Western World, and Science for the People. You can always connect with us on Twitter with the handle @YorkUniverse. Check out our website for show notes, content updates, and contact info at observatory.info.yorku.ca. Thanks for tuning in to York Universe. Clear skies and have a good night.
This idea appeals to people of all sorts of backgrounds. Why do you think that is?
It does, and I have to say it has greater appeal in places like the US.